Hello everyone. In the previous session, we talked a little bit about two tests we have in transformers to actually determine the internal parameters of a transformer. In the practical model of a transformer, we have four major components. Let me draw the schematic of the practical transformer very quick. We have RC, XM, R, and X. Okay. So we have open circuit test and short circuit test. Using the results coming from the open circuit test, we can actually determine these two components, RC and XM. And using the results coming from the short circuit test, we can actually determine these two components, R equivalent and X equivalent. Okay, so all these four parameters all together coming from the results of open circuit test and short circuit test. Let's work on an example. Let's say we have a transformer. We don't know anything about the internal parameters about these four components, so we have only access to the primary side terminal and the secondary side terminal, and we want to apply open circuit test and short circuit test to determine these four parameters: RC, XM, R equal, and X equal. R equivalent and X equivalent. The open circuit test is applied at low voltage side and the short circuit test applied at high voltage side. And I remember we discussed this in the class, why most of cases short circuit test is applied at the high voltage side. And the answer is because at the high voltage side we're dealing with the lower current. So that's the reason short circuit test is most of the times applied at high voltage side. Okay, so let's start with the results coming from the open circuit test. When this terminal is open circuit, so this branch is gone, right? Because nothing is connected to the primary side. To the secondary side. Okay. So RC is simply coming from this equation. V squared over P. P is the active power already given, and voltage is the voltage across this terminal is already given. Okay, so it's going to be 220 squared divided by 100. It's going to be 484 ohms. In the next step, we're calculating the current for RC, IRC. IRC is simply coming from this equation. The voltage across RC divided by RC, which is coming from the previous step, 484, is equal to 0.45 amps. There is a common mistake here, and we need to stay away from this common mistake. The current is given in the table. The current is 2.5 amps, okay? And a common mistake is subtracting IRC from this current and say this is going to be the current for XM. That's a common mistake. Please stay away from this mistake, okay? So we're dealing with an active component and passive component. Okay, we're dealing with a resistive branch and a reactor. Okay, a reactance here. Okay, so we cannot just simply subtract the IRC from the current given in the table and say this is going to be the current for XM. IXM is calculated in this way. (2.5) squared and this is equal to 2.46 amp. And then XM is equal to the voltage divided by IXM coming from the previous step. Is already given in the table, and then 2.46 is equal to, okay, so we have RC and we have XM. Now two parameters left. We need to determine R and X in this branch, okay? So these two parameters are actually coming from the short circuit test. Let's start with R. So the voltage is given in the table and we have the current. We can easily calculate the R. We can easily calculate the R here. So P is equal to Ri squared, therefore R equivalent is P is equal to 215 wattage divided by 4.55 squared. It gives us 10.4 ohm. One parameter left, X. We have V is equal to ZI, right? The impedance, the combination of R and X. So in a complex format, it's going to be R plus JX. Therefore, Z is equal to V over I. We already have V 150 and we have I. So it's going to be 150, 4.55 gives us and then X is coming from Z and R. We have Z from the previous step and we have R from this step, and it gives us X. Now we want to come up with the equivalent circuit for a practical transformer. These two parameters are coming from low voltage side, and these two parameters are coming from the high voltage side. So if I want to transfer everything to the low voltage side, this is VL and this is gonna be the secondary side but transfer to the low voltage, right? So we determine these two parameters from the low voltage side, right? There we go. 484 RC and 89.43 XM, okay? So this is going to be 484 and this is going to be 89.43. Another common mistake, we need to stay away from these two. R equivalent and X equivalent, we have values for both of them, but at high voltage side, okay? So at a different side, okay? So these two values are coming from the results, open circuit test result, low voltage side. So we have to have different values for R and X here. Let's say the turns ratio of the transformer is 2200 to 220. This is the turns ratio. So when we are transferring high voltage side, the parameters to the low voltage side, we will have a factor of 1 over A squared. When we are transferring components from low voltage to high voltage, we'll have A squared. Okay, let me write it down here one more time. From low voltage to high voltage, we'll have A squared, and from high voltage to low voltage, we'll have 1 over A squared. We discussed this a few sessions ago. Then we talk about impedance transfer. The turns ratio here is 10. 2200 divided by 220. It gives us 10 turns ratio. And we are transferring some components to low voltage side, okay? So we have to multiply this gentleman and this gentleman by 1 over 10 squared, or multiplied by 1 over 100, okay? So it gives us 10.4 times 1 over A squared gives us this. And same story for this. How about if we want to transfer to the high voltage side? So if we're transferring everything to the high voltage side, these two parameters will remain unchanged because they are already at high voltage side. Okay, so this is going to be 10.4 and the other two parameters are calculated at the low voltage side. We need to transfer them to the high voltage side, so we need to multiply them by A squared. So we'll have 484.00 and 89.43 whole. So this is going to be our transformer, schematic of the transformer, a practical model. While all components are transferred to the low voltage side, and here we have transferred all components to the high voltage side. Low voltage side, high voltage side.